Let's go for it. I'm going to pass out the tests. The grades are posted somewhere there. So if you go to my grade and look at raw scores or something, or I don't know where you find it, but they're posted, but I'm going to show it to you. Ngozi? Letitia? Is Letitia here? Letitia? Ms. Hawkins. Your first name is hard for me to say. How do you say that? Elchana. Okay, I've been trying to. All right, I didn't come up with that pronunciation. Enriqueta? Sandy? Miguel Hernandez. Alan Hernandez. Fergie. Aja. Is Aja here? Alex. Erica. Zena. Christian. Vanasco. Sophia. Juan Martinez. Jeremy. Jessica Lugo. Jessica. Going 3 times. Isaac. Albert. Robert. I can tell from that handwriting. See, Robert took that test with one hand. Not even his writing hand. He made a very good score. Vanessa. Mario. Balquise. Where's Balquise today? Gerard. I don't see Gerard either. Ms. Bay. Where is she? Where are all these people? She's usually sitting right there. Zaman. Yeah, Zaman. Say I'm missing people. Anthony. I know he's here. Lamb Michael. Is that how you say your name? Okay, all right. Marco. Monica. Nora. Timothy. Mr. Loza. Daniel Ramos. Maria Betancourt. Diana. Natalie. Eduardo. Summer. Joviana. Huh. Anybody come in and get one? Hi. Jessica. There's one in here. Okay. Oh, did you pass those sheets out, John? Yeah. Pass out the one labeled, well, you can pass them both at the same time. The one that says class activity 2. Yeah, okay. All right. All right. Okay, so the median grade on that test was which is half above and half below, was 73. The average was 72, so those were about the same. So that's not terrible, but that could be better. I like the median score to be higher than that. If you're one of the people who did not get a score that you are satisfied with, okay, then I did list up here some recommendations. They're pretty obvious things that you can work on to improve your score on test number 2 when that comes up, okay? So I forgot, you can look in the syllabus when test number 2 is going to be around the end of March sometime, okay? So it's after spring break, but around the end of March there is when our test number 2 will be. And so these are, things that, are pretty easy to determine, but I want to remind you of anyway that can help you, bring that test score up, okay, if you are in that boat, because one bad test score you can recover from, and but 2 of them, that's going to be really difficult to recover from, okay? So one thing, of course, is, and you do your homework 100%, or as close to 100% as you can get. So you've been really good about keeping up with the homework. So in general, the class has. So you want to continue that. But if you haven't been keeping up with your homework 100%, you really need to keep up with the homework. Okay. Another thing that can really help is visit John if you can in South 405 for tutoring, especially for the test reviews. But just in general, okay, visit John and get help. Now, if you can't go to South 405, you can go to the Math Center still, right, in North 925, right? So don't forget about the Math Center. It's not just John, okay? I think John gives customized help for the class, but you can also go to the Math Center, all right, in North 925 and get help, especially with your homework, okay, and the sample test. So I think one thing that some people did not do was they didn't pay close enough attention to the sample test, okay? So don't make that mistake again, all right? You need to go through that practice test, right, before the second test, all right? That will really help you with your second test score. And then in preparation for that second test, you need to review your homeworks and quizzes as well, okay? So, you've got to review your homework, review your quizzes, and do that practice test, right, before the next test. So one thing I noticed, I think several of you did not prepare well for the test, okay? That could be because I gave the test on Monday, so I don't like to give tests on Monday because I know, as I mentioned to you, that I know because I track this, students don't do homework on the weekend, okay? So I don't like to give tests on Monday for that reason, but this time we had to give the test on Monday. So if you were blowing off preparing for the test because it was the weekend, okay, then next time you cannot do that, all right? So you're going to have to try to find time, as difficult as it may seem with your schedule, to prepare for the test. You've just got to prepare for the tests, okay? There's just no substitute for that. Right, so I know all of your instructors tell you that, blah, 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 blah. It goes in one ear and out the other, okay? But now you're seeing the consequences of it, right, if you've got that score that is not what you want, okay? Just got to prepare for tests, okay? So that's what the practice test is for. That's what John's test reviews is for, right, okay? Another thing is the index card, okay? So I gave you the opportunity to write down on the index card things that you wanted to write down to bring into class. You need to think carefully about what you want to put on that index card, okay? That index card is not just an aid for you in taking the test. It's also a study guide for you, because in making out that card and thinking about making out that card, that will force you to remember the important things, right, okay, that you need to recall for the test. So that also helps you prepare for the test. So make out that index card carefully. I saw a lot of sloppy index cards. Look like you just scribbled something down 5 minutes before you came into the class, okay? That is just the wrong way to use the index card, okay? So make out that index card carefully. Who just came in? Hi, what's your name? Maria? Ah. Great. Okay. All right. So make out that index card carefully. Of course, you got to come to class. Y'all been very good about coming to class. So in general, attendance has been really good. So we want to keep that up. Okay. And then another really important thing is correct your mistakes on test number 1. Okay. So don't just look at that score and then say, all right, I got to do better next time, and then put the test away. All right. So you've got to look at that test and think about what it is that you missed on the test and why you missed it. So you really need to go back through the test and try to correct your mistakes, okay? So I recommend really going to John today or any day, really, but you can also go to the Math Center if you can't make it to John and ask John to help you with your test corrections, okay? So ask John to help you with correcting that test. You've really got to correct the test. If you just put that test away with a low score and don't learn from your mistakes, you'll have missed a golden opportunity to improve yourself for test number 2, okay? So this is a famous story about how the difference between A students and B students and C students and D students and how they look at their tests when they get them back. So A and B students, they really think about what it is they did wrong on the test and why they got it wrong, okay? C students just look at the test and look at what the right answer was and compare the two, okay? And D and F students, you know what they do? They look at their grade and put the test away, all right, okay? That is the behavior of D and F students versus C students versus A and B students. So if you want to be an A or B student, okay, then you really need to think about, why did I miss that question? Why did I not know that? Okay, because all these things that we're going over were, in the homework or on the practice test, right? Okay, why did I miss that? And then try to correct that, right? So that if that problem comes up again, you won't miss it again, right? Okay? So I know you've heard this over and over again throughout your life, but that's just the truth, okay? That's just the facts, all right? So you really want to correct those mistakes. Take advantage of the calculus currency, okay? So a lot of y'all are leaving dollars on the table by not doing the extra credit assignments, okay? And not going to tutoring, okay? You really want to take advantage of that. Remember, you can buy points on your midterms, right? With your calculus currency at the end of the semester, it's $3 per point. So if you've got a bank of 20 points, that means you've got 6 or 7 points already that you could contribute to that exam score, okay, if you so choose, all right? Some of y'all have quite a big bank already. I think the highest person has $36 already. That person just needs $24 more, and then with 60, they could buy out of the final, you see, okay? So, and you want 25 for sure in the bank so that you can replace that low test score with the final exam score. So if you're looking at a low test score, you can replace that with the final exam score if you make sure at the end of the semester you got $25 in the bank. Okay, so part of that you can earn through meeting the attendance policy, because that'll give you $15, and then going to tutoring or doing extra credit assignments can get you the other 10. Okay, so so you want to take advantage of the calculus currency. Now, some of you are going to notice that you lost currency, right, for this test, because there is a penalty for making low score on the test. If you make below 60, you're going to lose $10. If you make below 70, you're going to lose $5. Okay, so I've already subtracted that from your currency. That's another reason to prepare for test number 2, so you do not lose currency. Okay, right? Okay. Don't lose currency. Now, you're lucky that I can't enter negative scores, because some of you would be below 0 on your calculus currency already, okay? But I can't enter negative scores, so the worst you can get is 0, okay? And but some of you are unfortunately at 0, okay? So got to think about that. At least don't violate the attendance policy, so that you can earn 15 at the end of the semester, or extra 10. You can replace that low score with the final exam. Then, of course, another thing you can do, this is not always easy to do, but if you can, form study groups with your classmates, right? So study with someone in class. It's always good to study with someone else instead of studying alone, okay? That usually makes it more fun and a little bit more palatable to study if you're studying in a group. So if possible, try finding someone or a group of people that you can study with for the next test, okay? All right? So people that are showing up for tutoring, right? That would be a natural group of people that you might want to consider talking to and seeing if you can get together and study and prepare for the next test, okay? And you can even start before the next test, okay? So a lot more fun to study in a group than it is to study by yourself, okay? Especially something like calculus, all right? Okay? All right, so those are positive actions you can take to improve your test score for test number 2, right? So you're not in a hopeless situation if you made a low score, okay? You can still, with enough currency, replace the low score with your final exam score, okay? So you've got that option, right? But you can't make 2 low scores, right? Because with 2 low scores, then you're really behind the 8 ball in that case. What are you looking for, John? Oh, okay. All right. So can still recover here, right? If you made a low score, but you don't want to do that twice, okay? All right, now, so enough of that. Now, well, not quite enough of that, all right? So I passed out to you an activity. The first page of this we're about to go over now as part of the class today. It looks kind of intimidating because we've got that big table to fill out, okay? But that actually is kind of fun. The second part is maybe not so much fun, all right? Okay, if you look on the back, all right, all right, I want you to think about this. So if you made a score on test number 1 that you liked, and 11 people made A, okay, yay, I like that, okay? So I had 11 A's, that's very good, all right? So if you made a score that you like, right, okay, think about what you did to prepare for the test that you're going to continue doing, okay? So if you were doing your homework religiously, then, say, I'm going to continue doing that, right? Okay, if you did the practice test, then you're going to continue doing that. So at least 2 things that you did to prepare for the test that you're going to that you're going to continue to do if you made a score that you like, okay? Now, if you did not make a score that you like, all right, so if you made a low score, then I want you to write down 2 things that you did not do, okay, that you think you didn't do or you're going to do differently to prepare for test number 2. All right. So I gave you a long list there of things of recommendations, but you can write down other things as well. Okay. Right. I don't know. Stop getting drunk the night before the test or something like that. Right. Okay. That you're going to do to help you with test number 2, right? Okay. I gave you a slot for 4, but I want 2. So write down just quickly there 2 things, right? Either to maintain your great test score, okay? Like, what was your name? Yeah, made a good score. So 2 things you're going to do to continue making that good score, okay? Or 2 things that you need to change, right, for test number 2, okay? So write that down for me. And then we'll go and fill out the second part, but the first part of this activity. But don't lose that now, because I'm going to hold your feet to the fire. All right, okay. When test number 2 comes around, so I give you a couple minutes to think about that. Okay. Now, look, there's no reason beating yourself up. Well, there is a little bit, okay? I mean, if you made a bad score, right, okay, you're not going to feel great about it. So, and you're not going to feel great about it, right? But the thing is, you don't want to lapse into self-pity here, right, and say, I cannot do calculus, I'm no way I can ever pass this class, because that is not true. I can promise you that everyone in this class can pass this class, all right, okay? But you may have to do some things differently in order to pass the class, okay? One other thing you can do that I should have put on the list. I don't know why I didn't put this. You can certainly come and visit me, okay? All right? So John is a really good tutor, but I am better than you, John, okay? So you can come and visit me and get help as well. I'm not, that mean, okay? I'm a little bit mean, but not that mean, all right? And so you can come and visit me and get help with correcting your test, for instance, okay? Or preparing for the next one, all right? So visiting Dr. Waller in his office, South 655, okay, is another option for helping you prepare for test number 2, okay? I know that's a really scary option. Students don't like to go visit their professors, all right, okay? But, if you thought of everything else, right, and everything else has failed, then, you might have to, pull out the stops and try that. So write 2 things down. Everybody has to have 2 things written down, okay? Everybody has to have 2 things written down, so you've got to write down 2 things, okay? So if you didn't write down 2 things, you just turn it back over and finish writing down the 2 things. Okay. Because I'm going to collect this, and this is going to be part of your class participation grade, so you've got to write things down. Did you write them down, Fergie? Okay. All right. Only 2, right. Okay. But you can write down more, okay? You can do more things. Okay, now we're going to, so while you're finishing that up, let's switch back to our notes here. All right, so Now, I know you may have questions about certain problems on the test, right? Okay, I hope you do have questions about certain problems on the test, especially the ones that you might have messed up on again, right? So that's part of the test correction process, right? So you can take those questions to John, or you can bring them to me, or you can bring them to the Math Center, right? And try to figure out, what was the correct answer for a particular question. The answers are posted, however, so if you go to the Blackboard page, right, okay, if you go to the Blackboard page, you can find those on the Blackboard page under the sample test link. Oh, by the way now, before we get into the notes, so remember now, if you go to My Grade, I don't know if this looks the same for you, but if you go to My Grade, okay, and that will show you your current grade, right? Okay, and your average in the various categories. But if you go to so of course mine is low because I haven't been doing the homework. But if you go to the raw scores, then and click on these various categories, right? It will show you, the scores on everything that you've done so far. Since you've only taken one test now, your test score is going to show up there. But if you want to see your amount of calculus currency that you've got in the bank, you can see that also right there, correct? Okay. And then remember on the syllabus, it discusses, right, all the different ways that you can use that currency at the end of the semester. All right. So the answers are posted. All right. So let's go back now to what is a familiar problem to us now. And actually, this is one of the better problems on the test in terms of how the class did as a whole. Okay. So I've got here a graph made of this particular function, 4 minus 1/4 x squared, and we want to find there the rate of change, okay, right, at the input 2, all right? So remember, that's how we express rate of change, right, at a particular input, is by using the name of the function, which in this case is f, right, and then we use that, that prime symbol there, right, to indicate rate of change. So that's asking us for the rate of change at the input 2. So the only way we know, well, not the only way, but the one way we know how to do this at this particular time, right, is to, since I've got the graph drawn here, we can try to estimate that rate of change, right, the way we did it on the test, which is just by hand here coming in and drawing a tangent line, okay, by hand coming in here and drawing a tangent line to the curve right here at the input 2. So there's the input 2. So let me try to freehand a tangent line here, so I'm not going to get it really good. So there's a tangent line, right? Okay. And then we could estimate the slope of that tangent line, right, by picking off a couple of points on that tangent line and calculating the slope of that tangent line, and that would be our estimate for the rate of change. So actually, let's actually try that here and see what we come up with for that. For our estimate there for f prime of 2. So I've drawn the tangent line already. That's a decent tangent line. It's maybe not perfect, but it's okay. Most people did pretty good at drawing the tangent line. At least 35 out of 40 of you, I think, did pretty good at drawing the tangent line when I asked to do that. So that's good. Okay, so there's the tangent line. And now we've got to pick 2 points off of the tangent line, right, to calculate the slope. Okay, and so most people knew they had to pick 2 points, but they didn't always pick 2 points on the tangent line. This was a tragic mistake that some people made. Okay, 1 point on that tangent line is this one, right? Okay, which is right here at the input 2. We definitely know that point is on the tangent line, and the matching output there, you can't really see it very good in this graph, but the matching output there happens to be 3. Okay, so 1 point on the on the graph of that tangent line is this point right here, which is 2, 3, right? And here's another point, I'm just thinking, on the tangent line right there on the y-axis, right? So if I can figure out what the if I can estimate what the coordinates of that point is, then I'll have my 2 points on my tangent line. The tragic mistake that I was referring to that some people made is when they were picking out the 2 points, they didn't pick points on their tangent line, they picked points off of the curve, okay? Remember, if you want the slope of the tangent line, you've got to pick points on the tangent line, okay? So don't pick, since you picked this point on the curve, don't pick another point on the curve, right? Pick actually another point on the tangent line. So let's pick that point, which looks like it's going to be, is that 5, I think? Okay, all right. So looking at the graph, I think that is, yeah, this is 2, 3, 4, so that would be 5. So another point here would be 0 on the x-axis and 5 on the y-axis. All right, and now let's calculate that slope now with those 2 points. So we have 5 minus 3 over 0 minus 2. So that's 2 over negative 2, which is negative 1. Okay, so I'm thinking there that the slope of that tangent line is minus 1. So there's my estimate for my rate of change. I think it's approximately negative 1. But I know this is only an approximation because I didn't, I can't draw the tangent line perfectly, right? Okay, and I probably can't pick the points off of the tangent line very perfectly either. So this is only my estimate. Now, it may turn out that it's, a really good estimate, but it also could be a little bit off, right? And different people could come up with different estimates. That's the flaw to this approach for calculating rates of change is, everyone's going to draw the tangent line slightly differently, and people are going to pick points off the tangent line slightly differently. So people are going to get slightly different estimates for this rate of change. And so you may have done, gone through this exact same process perfectly correctly and got a different estimate for the rate of change than I get, right? Okay. So what we want to do today now is start making this process a little bit more exact, a little bit more analytical, so that all of us will come up with the same estimate for the rate of change, okay? And actually come up with exactly the correct value for the rate of change, okay? And not just relying on an estimate. But there's my estimate, all right? Minus 1. By the way, now, that estimate could be at least... it's reasonable that estimate could be okay, because I can see that tangent line has negative slope, right? That tangent line has negative slope, so I'm expecting that rate of change to be negative, right? The curve is decreasing right here at 2, at the input 2, right? The curve is definitely falling, so you're expecting the rate of change to be negative. Boy, that problem on page 1, at the bottom of page 1 on the test, gosh, so many points lost on that one, okay? That really drove me crazy. That was only worth 6 points, but on average, probably everyone lost 3 out of those 6, okay? But that was really the easy points on the test, okay? Because just from looking at the graph of that curve, you can estimate whether the rate of change is positive or negative, right? Okay, it's only whether the graph is increasing or decreasing that determines whether the rate of change is positive or negative. So since this curve is decreasing right here at the input 2, then we know that rate of change has to be negative. Maybe it's not exactly negative 1, but I know it's got to be negative, right? Okay. Okay. So. All right, so there is our estimate for the rate of change. But now, how can we do this? How can we try to come up with a way of computing this rate of change so that we're not all getting wildly different estimates, all right? Okay, that's what I'm going to show you right now, okay? And now we're going to actually, this is, in a way, this is where we're introducing the same idea that Isaac Newton used, okay, when he was thinking about calculus. Because you see, Newton didn't have methods for drawing these nice graphs like we do, okay. Newton didn't have computers or calculators, right, okay. So, you know, what idea was Newton using to find these rates of change? Okay, all right, so let me go now to, let me switch now here to Desmos, okay, and now you can pull out there your, look at that class activity 2, the first side, okay, because we're now going to start filling that out, all right. So you're going to have to fill this out for me while we're looking at the Desmos here, all right. Okay, here's the idea that we're going to use, okay. Here's the idea that we're going to use. All right, so this is that same curve. This is 4 minus 1/4 x squared. There's nothing special about that curve. I just picked that off as an example, okay? All right, and see what I've done here now is I have drawn not a tangent line, right? I haven't drawn a tangent line, but what I've really drawn is, what kind of line is this called? Yeah, that's a secant line, okay? So you know when you calculate the slope of a secant line, you're not calculating the instantaneous rate of change, you're calculating what type of rate of change? Begins with an A. Yeah, you're finding average rate of change. So, so the slope of this secant line is the average rate of change, right, from this input, which happens to be 2, okay, over to this input, which in this case happens to be 6, all right? So, so here's the way I've expressed that, here's the way I've expressed now that average rate of change. So I'm starting at the input 2, so that's the value that I'm going to call A here, okay, right? So A is 2. But now what I've done is, starting at 2, I have moved over a little bit to the right of 2 by a little amount, okay? Let's see, what amount have I moved over from 2 to get to this second point? Let's say I'm going from 2 to what? No, not 8. Look closely there. 6, right. I'm going from 2 to 6, right? So I've gone over from 2, I've gone over 4 units, okay? I've gone over 4 units. That amount that I'm moving over from 2, I'm going to refer to that as h in this chart, okay? That's called the increment, all right? So I'm going to call that the increment, all right? So I've started at 2, and I've moved over a little bit to the right of 2, okay? All right, so look at this table. There's 2. There's my increment, which is 4. So if you take 2 and add 4 to it, of course, my pointer is dying on me. But if you take 2 and add 4 to it, let me just point at it. If you take 2 and add 4 to it, of course, you get to what? What does that show right there? 6, right. So those are the two values I'm going to use to calculate my average rate of change. I'm going to go from 2 to 2 plus 4, which of course is 6. And there is the formula for the average rate of change, okay? So that's f of 6, 2 plus 4, right, minus f of 2, my a value is 2 here, divided by the 2 plus 4, which is 6, minus the 2. Okay, so all this formula here is doing is calculating the average rate of change. Okay, so a little bit more than 2, right? Okay, I'm computing the average rate of change from 2 to a little bit more than 2, and there's the value that I come up with. It happens to be minus 2. So how do I fill out that? Y'all help me here now. How do I fill out that first? How do I fill out that first row in my rate of change table here? So remember, the value I'm starting at is 2. We have to calculate f of 2. F of 2 happened to be 3. If you plug 2 into this formula, you'll get 3. Okay? Just try it there. It's 4 minus 1/4 times 2 squared. Well, 2 squared is 4. So you have 4 minus 1/4 times 4. 4 minus 1 is 3. Okay? All right. There's a plus h. So what was a plus h? 6, right? What was f of a plus h? Let me look back there and see. So f of a plus h was what? No, f of a plus h was what? -5, right? Yeah. So for this function, at the input 6, the output is -5. That's what that is telling you there. Okay. All right. So this is -5. And now all we're putting into that last column is what was that average rate of change. Okay. Well, what did Desmos tell me the average rate of change was? So I could have done that by hand, but Desmos is doing it for me. And we come out with what? -2, right, okay? So what you're going to fill into that last column there is -2, all right? So what we've managed to do there is calculate an average rate of change. So you're thinking, okay, that's really exciting. I've done now about 40 average rates of change so far, right? I mean, are we ever going to get away from these average rates of change? This is getting boring, right? Okay? And the answer is, yeah, we're going to get away from it real shortly here. All right, okay? But we're starting with an average rate of change. Now, look, does that secant line look like the, because what we're trying to calculate is the instantaneous rate of change, right? I don't want to calculate an average rate of change. I'm trying to calculate the instantaneous rate of change right here at the input 2, okay? So you know to calculate the instantaneous rate of change, you need a tangent line, not a secant line. Well, does that secant line look like the tangent line? No, not really, right? It kind of. It's got the right slope, right? It's going down, but the tangent line shouldn't cut through the curve in 2 points, right? Okay, secant lines cut through curves in 2 points, but tangent lines are just supposed to hit the curve at 1 point, right? Okay, so that secant line, not really the same as the tangent line, correct? So the slope of that secant line is not going to be the same as the slope of the tangent line, right, Enriqueta? Okay, yeah, but now here's what I'm going to do, right? And so here's what Newton thought to do. Newton said, okay, all right, so that secant line, not quite the same as the tangent line, but I can make that secant line look more like the tangent line by making that increment a little bit smaller, making that h value a little bit smaller. So I'm going to cut that increment now down to 2. That value from h, I'm going to move it from 4, I'm going to move it down to 2, all right? Now that didn't seem too exciting at first, okay? But when you see what happens on the graph, so let me change that to 2. When you see what happens on the graph, then it gets a little bit more exciting. All right, so now let's draw this new secant line. So this is the secant line that goes from 2 over to 4, okay? Not from 2 to 6, but 2 over to 4, because I changed the increment to 2, all right? Okay, and what you'll notice is, well, that's still very clearly a secant line, right? It's not a tangent line. But that secant line looks a little bit more, doesn't it, like the tangent line that we're after, correct? Okay? That was exactly what Newton was thinking in his head. He said, if I change that increment a little bit, I'll get a secant line that looks a little bit more like the tangent line that I really want, okay? It's not the tangent line that I want, but it looks a little bit more like the tangent line that I'm looking for here, right? Okay, now let's fill out the second row of our table here, right? Okay, so there are all the values. What's the a value? It's still 2, right? Because we're trying to calculate the instantaneous rate. So you don't change the first column. But what's f of a? That stays the same? 3, right, okay? Because the a is staying the same, so f of a stays the same. So you keep the 3, okay? The increment now I change to 2. The h value I change to 2. So what's a plus h now? What does it say there? 4, right, okay? So now you can change that to 4. This is 4 now. What's f of a plus h? 0, right. Yeah, 4 happens to be an x-intercept there, okay? That crosses the x-axis right there that curve crosses the x-axis right there at 4. And what is the slope of that secant line now? -1.5, okay? All right. All right, well, okay, so that secant line looks a little bit more like the tangent line, but you know, if you had drawn that as the tangent line on the test when I told you to draw the tangent line, I would have counted off, right? Because I'm merciless. So I would have said, that is not a tangent line, that is a secant line, dummy, okay? And I would have counted off, right? Okay? So still not, we still don't have the tangent line here, right? Yeah, but now guess what we're going to do? we're going to do the same thing. Now we're going to reduce the increment a little bit more. And we're going to make the secant line look a little bit more like the tangent line. So now I'm going to reduce the increment down to 1. Okay? And look what happens when I reduce it to 1. That secant line, boy, that's hard to even tell that does cut through the curve, but it does cut through the curve. Okay? So that is a secant line. But notice that's looking a little bit more like the tangent line that I want. Now let's fill out that third row, okay? So fill out that third row. The A is 2, right? You got to fill it in here now, okay? The A is 2. The f of A stays 3. The h now has changed to 1. Is that what I have in there, 1? Yeah, okay. The h is changed to 1, all right? The A plus h now is 3, okay? See, because now I'm drawing the secant line over to 3, not to 4 anymore. The secant line is now 3. What's f of A plus h? This is where the calculator really helps. What is it? So what is that output there? That's 1.75. Hard to tell, but that's 1.75. Okay. And what's the slope of this secant line? Negative 1.25. Okay. All right. Now you see how the game is going to be played. Because now I'm just going to keep on reducing the increment. So now let's go down a little bit more. What's the next one that I have for the increment? 0.5? And there's still a secant line because that secant line is crossing the graph at 2 points. But now that's very much starting to look like a tangent line, right? Okay, let's fill in the values. So y'all fill in the values for me here. A is still 2, f of A is still 3, the h is now 0.5. What's A plus h? 2.5. I'm calculating the tangent line from 2 to over to 2.5. What's f of 2.5? Well, that happens to be 2.4375. You could do that by hand, but there it is. It's 2.4375. So that's what this output is. That happens to be 2.4375. Okay, if you don't believe it, just try it. And then what's the slope of this secant line now? Negative 1.125. Okay. All right, now let's keep going here. So now I'm going to reduce that down to what I put? 0.1? 0.1. Okay. And there are the 2 points on the curve. You can just barely tell now there are 2 points on the curve. Okay, so you have to really sort of squint. So you really do have a secant line there. That's not a tangent line. Okay, you really do have a secant line there. It's not a tangent line. Okay, but notice it's starting to look very much like the tangent line would or does when we draw that tangent line, right? So now fill out that next row. So A is still 2, f of A is still 3, the increment is 0.1. So f of A plus h is 2.1. So this second point is 2.1. F of A plus h is 2.8975. And what's the slope of my secant line here? Minus 1.025. Did y'all fill that in? Okay. And see now, because we've got this wonderful Desmos here, we can just keep doing this, you see. So let's go to what's the next one I have? 0.01? Oops. And at that point, can you even tell that's a secant line anymore? Really not, right? You can't even distinguish the 2 points. That really is a secant line, though. Okay, it really does cross the graph at 2 points. You'd have to blow the graph up there to really see it. Okay, but already that is almost looking like the tangent line, right? Okay, it really is a secant line, though, because it's going from. Where did I put my? Where did I lay my pointer down? Yeah, so it really is going from 2 to 2.01, okay? So what we're actually calculating here is the average rate of change from 2 to 2.01, okay? So that really is a secant line. It does cross the graph in 2 points. It's just that the 2 points are so close together, visually we can't distinguish between 2 and 2.01. They're only 1/100th apart, right? Okay, so fill that in. The A is 2, the f of A is still 3, the h is 0.01, the A plus h is 2.01, f of A plus h is 2.989975, and what's the slope of the secant line there? Minus 1.0025, okay? Well, look, there's no reason now that we cannot continue this. In fact, we can make that increment infinitesimally small, okay? Especially with the calculator, and even do the calculation. So is the next one I have 0.001? Yeah, okay. And when you change your increment to 0.001, I see still, well now for sure, right? You cannot distinguish that that's even a secant line, right? Okay. It looks like the tangent line, correct? Okay. It looks like the tangent line. But it really is a secant line. It does cross the graph in 2 points. It crosses at 2 and when x is 2, and it crosses when x is 2.001. Okay. And what's the slope of that secant line there? Minus 1 point, you got to get the decimal places right, 0.00025. Okay. All right. Let's put in one, we'll just really see if it's going to, oops. That's my slot I wanted to. Okay, let's try one more here. And see, really, that still is a secant line, but it looks almost like, certainly like a tangent line, right? So what do we have there at that last column for, I'm sorry, that last row for the slope of our secant line? Minus 1.00025. Okay? All right. So let's fill in that, y'all help me fill in that last row there of, let's fill in that last row. So f of A is still 3. What was A plus h? So we were calculating the slope of the secant line from 2 to 2.0001. Okay. What was f of 2.00001? 2 point, can I even get it in here? What? 9, 9, 9, 8. It's too long? Well, okay, close enough there, right? Okay. And what was the slope there of my secant line? Negative 1.000. Were there 3 zeros? 4 zeros? And a 2.5. What was this one? Minus 1.00. 3 zeros and a 2.5? Yeah. What was this one? 2 zeros and a 2.5? Okay. Now here's what I'm going to tell you. These first 3 columns are kind of not really meaningful to me. I mean, these first few columns are not really meaningful. This is really the column I'm looking at, that slope of that secant line. Okay, because again, here's what Newton thought. Okay, we're still looking at slopes of secant lines. Okay, these are all slopes of secant lines, right? Okay, but what Newton imagined is, gee, if I continue this process, if I continue making that increment smaller and smaller and smaller and smaller until I make that increment infinitesimally small, okay, until I make that increment infinitesimally small, it looks like these slopes are all converging to what limiting value? What does it look like all those slopes are moving toward? -1, right, okay? So that's what Newton said. Newton said the slope of the tangent line must be -1, because if I draw these secant lines that are looking progressively more and more like the tangent line, their slopes are getting closer and closer. I can see their slopes are getting closer and closer to -1. So the rate of change, the correct rate of change must be what? -1. That was Newton's, that was Newton's reasoning. Okay, if I keep making that increment smaller and smaller, these rates of change are going to get closer and closer to -1. So the slope of my tangent line must be what? -1, right. Yeah. How else could it be something different? Yeah. The slope of the tangent line has to be -1, because when I make those secant lines look more and more and more like the tangent line, their slopes are getting closer and closer and closer to -1. So that has to be the correct slope of the tangent line. Got to be exactly -1. So what's f prime of 2? Got to be -1, right? Because that's the same as the slope of the tangent line, you see. Okay. To me, I don't see, I don't see any flaw in that reasoning, right? Okay. When I make those secant lines look more and more like the tangent lines, their slopes, I've calculated them there, they're getting closer and closer to -1. If I continue this process, they're just going to get more and more close to -1. Okay. So that tangent line has to have slope -1. Okay. That's just what I see here, right? Okay. The slope of that tangent line has to be -1. Now, you might say here one thing. Now, look, you may want to get clever and say, well, Dr. Waller, why don't you just make the increment 0? If you make the increment 0, then won't that give you exactly the slope of the tangent line? But see, what happens if you make the increment exactly 0? Yeah, this comes out to be undefined. Why does this come out to be undefined? So you cannot ever make the increment exactly 0. You can get it close to 0, but you cannot make it exactly 0 in your calculations. You can imagine what happens when the increment gets close to 0, but you cannot exactly set the increment close to 0. Because, notice this comes out to be undefined. Why is that true? Because look at, what is that denominator really? A plus h minus a. Well, you can just cancel the a's there, and what do you end up with? H. So if you put in here h equals 0, you're going to end up dividing by 0, and that's why that slope slope of that secant line turns out to be undefined. So you cannot ever exactly calculate that slope when h is 0, but you can imagine what happens when h gets infinitesimally close to 0. Okay, and we can see, those values are getting, those slopes are getting very, very close to -1. There it is. Okay, so notice, I think we all wrote down -1. We all came down with an agreement there that f prime of 2 must be -1. Oh, we had a pretty good estimate to start with. Okay, I thought we were going to have a very good estimate. I should have tried that beforehand, and by freehand came up with a lousy estimate. Okay, but I actually draw my tangent line really good. I guess I've been doing this long enough. Okay, that I know how to do that. All right, let's try that again, okay, because 1 is not enough. And so I think we have just enough time to try another one. Did you pass out the second sheet, John? Okay, right. All right, so now I want you to look at the activity 3, okay? And we're going to do this again in class, so we've got just enough time to finish this one, okay? We're going to do this again in class. And then, if you look on the back, I have one for you to do. Okay, I have one for you to do on your own. All right, I want you to calculate with that information f prime of 57. But I'll show you the link to get to this page in Desmos. Okay, the link to get to this page is on the WebAssign webpage. So you can fill this one out on your own. Okay, using Desmos at home. Okay, that's what you're going to bring back to me on Monday, okay? But we're going to do the side 1 in class, all right? Okay, so let me pull that one up. And all right, so it looks like this. So this is a profit function. This is an applied example. This is a profit function for Priscilla's premium chewing tobacco, okay? All right, and we want to calculate the rate of change. This is what we're getting at the input 6. We want to calculate the rate of change at the input 6. Okay, so this process that we just went through that long process of filling out that table and choosing smaller and smaller increments and calculating average rates of change for smaller and smaller increments, that process is called computing a limit, all right? So we're calculating the limit of the slopes of secant lines as our increment gets closer and closer to zero, okay? You can summarize that whole process here, though, in just one line of mathematical notation. You use here the word limit, but we abbreviate it to just LIM because we're just lazy, okay? And then notice that use a subscript there below that word, and that's H arrow 0. So that means what is the limiting value, okay? What value is this quantity approaching as the increment gets closer and closer to 0? What is this quantity? This quantity is nothing more than an average rate of change, okay? That's all that is. That's an average rate of change starting at 6 and going over to a little bit more than 6. The increment gives you an average rate of change to a number a little bit more than 6, all right, okay? And you're going to make that increment get smaller and smaller and smaller. You're going to calculate these slopes of secant lines, these average rates of change, as the increment gets smaller and smaller and smaller. And then you're going to try to project, okay, what would happen if that increment gets infinitesimally small, all right? That will give you your estimate for your, not your average rate of change, but your instantaneous rate of change, okay? All right, so let's go back here to Desmos and let me see if I can call that one up. Ah, there it is, okay? All right, so there is that's Priscilla's profit function, okay? So this function outputs the profit, the daily profit for the sales of Priscilla's chewing tobacco, okay, based on what the demand is. The demand is the amount of sales, okay? So if you plug the amount of sales into this function for X, you will get the daily profit, okay? Yeah, I got the wrong. We'll fix that one. Okay, yeah, right. When I saved this example, I saved it with 3. Okay, yeah, all right. So, but that's what we're going to be changing a lot in this example anyway, right, is the increment, okay? So we're starting at the input 6, right? So here's, you can start filling out the table now. So what's P of 6? I had to change it to F because Desmos doesn't like P for a function name, okay? So I changed the P to F. All right, so what's P of 6? 128. So you can fill in there 128 down that first column, and that's always going to stay the same because we're not going to change where we're starting at. We're always going to start at 6. All right, now what we are going to change here is our increment. All right, so in that table, I started with an increment of 5. So let's start with an increment of 5 here, okay, just so we can match the table, okay? So there's an increment of 5, so 6 plus 5 would be 11. So we're calculating the average rate of change in the profit from 6 over to 11, okay? And there's that secant line that we've drawn, and the slope of that secant line, so by the way, F of 11, P of 11, I'm sorry, turns out to be 143. So you can fill that in. P of 11 is 143. And here is the average rate of change. Here's the slope of that secant line. It's exactly 3. And so you can see that secant line doesn't look anything like a tangent line, right? Because to calculate the instantaneous rate of change at the input 6, we need to have a tangent line at the input 6, right? And this secant line does not look like that tangent line for the input 6, right? But we're going to start making that secant line look like that tangent line by changing our increment. We're going to make our increment smaller and smaller, right? Okay, so y'all got the first row filled out there? Okay, so that first row is not very helpful because that secant line doesn't look anything like that tangent line is supposed to look, right? Okay, all right, now let's change the increment. So my next suggestion was what? Change it to what? 2? Okay, and that's looking a lot better, isn't it? That secant line is looking a lot more like the tangent line at the input 6. Oh, by the way, the fact that P of 6 is 128 tells you about Priscilla's, it tells you something about Priscilla's profit. If Priscilla sells 600 pounds of chewing tobacco in a day, her profit is going to be 128. I think that's 128 times 100. Okay, so it's $12,800 or something like that. Okay, but in your table, just put in the 128. Okay. All right. So got the second row filled out there, right? So what is the slope now of the secant line? It's gone up quite a bit, right? It's what? 9, right. Okay. So now the slope of the secant line is 9. All right, now let's try the next one. What's the next one? 1. Okay. And see, that's looking even more like a tangent line. And what's the slope of that secant line? It's gone up to what? 11. Okay. So we're sort of just beating around the bush here, right? Because we've really got to make those increments a lot smaller, correct? So y'all got that next row filled out? What now? What now? F of 7 is 139. Yeah, 139. This is 139. And the slope is 11.
Wait, how do you get the 139? What do you add?
How do I get that?
Yeah.
Well, if you want to do it by hand, well, you know A plus H is 7, right? Okay, because 6 plus 1 is 7. So if you actually wanted to calculate that by hand, you would take the 7 and plug it into the formula for X. Okay, so if you take 7 and plug that into, move this down. If you plug 7 into your profit, yeah, that is P of 7. P of 7 is 139. Yeah, if you plug 7 in there and just do the calculations, you'll see it comes out to be 139. Yeah, okay. So we've just, saved you all that arithmetic. All right. Okay, so P of 7 is 139. All right, and the slope of this secant line, we can still see that's a secant line, is 11. Okay, that looks like a really big slope, but these are large values. That's why the slope is so high. Okay, all right, so now we're kind of beating around the bush. So now let's get that increment kind of a lot smaller. So we want to go down to 0.1, right? Okay. And now you can see, whoops, I really can't even tell that's a secant line anymore, right? Because the points are so close together that I can't tell that this is a secant line. But it is a secant line. So what we're actually calculating is the average rate of change from 6 to 6.1. Okay? So we're going from 6 to 6.1 here. And F of 6.1 or P of 6.1 is 129.28. So if you plug 6.1 into your profit function. Oh, I skipped 0.5? Oh, sorry about that. All right. Well, that took all the fun out of it because that's definitely a secant line, right? Okay. Sorry. Okay. So from 6 to 6.5, the slope of our secant line is 12. Okay. P of 6.5 or F of 6.5 is 134. So if you were to plug 6.5 into the profit function, you would get 134. You can just try it and see that if you want to do that. All right, now let's go to 0.1. Is that the next one? Okay, now let's go to 0.1. And now, again, the secant line really looks like a tangent line, right? So can y'all fill that out? 6.1, 129.28. 129.28 is the profit at 6.1. And now the slope of that secant line that looks like a tangent line is 12.8. Did y'all get that filled in? What's next now? 0.01? And I bet y'all can already make a projection here. If I continue this process indefinitely, what is that slope moving to? 13. Yeah, I think so, right? Okay. But at 0.01, the secant line still has slope 12.1. 0.98. Okay. Do we do one more? Or do we do two more? Did y'all get that one written in? Okay, so let's try 0, 1. Is that right? And you can now see what's happening. Now your slope of your secant line is not changing very, very much, right? Okay, it went from 12.98, now it's 12.998. Well, I bet I can predict if I go down to h equal 0.0001, I bet it's going to be 12.9998, I bet. Let's see if that's correct. So did y'all get that? All right, so let's try one more. 0 there. And, oh, yeah, I was right. Okay. Now the slope of the secant line, which looks very much like a tangent line, right? Okay, is 12.998. 9998. So, you got that written down? So indeed now, what is this limit? In other words, if you keep making your increment closer and closer to 0, this slope, right, is going to get closer and closer to what? 13. Must be, right? How could it be anything else? Yeah. So that limiting value there has got to be 13. What else could it be? And that tells me then that the instantaneous rate of change, the slope of my tangent line, must be what? There we go. There it is. I think everyone is going to come up with the same value there, 13. Neat, huh? Well, kind of. In a way, we've made some progress. All right, because now I think we can all, by going through this process, we can all arrive at the same estimates for our instantaneous rates of change. But this process is kind of clumsy, isn't it? Because we have to fill out this whole darn table, right? And we still had to rely on the computer, right, Summer? Okay, so in practice, this is probably not really practical, right? Okay, right? Because it's just going to take too darn long, correct? Okay, to compute an instantaneous rate of change. So we've got to figure out some way to speed this up, okay? We've got to figure out some way to speed this up. But at least now we see what the idea is, right? Okay, we're going to estimate these instantaneous rates of change, these slopes of tangent lines, by taking secant lines that look more and more like the tangent line, right? Okay, calculating their slopes and then seeing what those slopes are moving toward, right? Okay. All right, now, so that's our next big goal, which we have to do on Monday is, okay, how, I've got to speed this up, right? Because this, I can't be filling out one of these tables every time I've got to calculate an instantaneous rate of change, right? Because that's going to take forever, right? Okay, so how can we make this go a little bit faster? All right, now, so on the back, okay, you've got another problem, all right? This one is about the amount spent on men's underwear, okay? This is real data there, okay? So you're going to think it's kind of amusing, but this is real data, okay? And so I want you now to calculate, all right, by Monday, this limit, okay, for this function, all right, going through exactly the same process using Desmos, all right? Now, the question is, how do I get to that? All right, let me show you then how you can get to that page, okay? Yes, we are going to turn in that paper, and that's going to be one of your homework grades. So when you go to WebAssign, okay, when you go to WebAssign, right, there, right at the top in the announcements, there's a link to that average rate of change table that I just showed you. So if you click on that, it will open it for you, I hope. Okay. There it is. All right. Now, when it opens it, it's going to open it to that first example that we started with. So you will have to change this formula, right? Okay. You'll have to type in the formula for that underwear problem on the back of that activity. Okay. And then, of course, you've got to change the increments, right, to fill in the table. All right. But that's all you have to do to fill in the table. And then use the values from the table, right, to estimate what that requested instantaneous rate of change is. Okay, so you can get to this easily, right? And I want you to turn that in on Monday. Okay, I want you to turn that in on Monday because that's going to be a homework grade. Yeah, the one on the. Oh yeah, this one. Give me today. Okay, the activity number 2, and then the class activity number 3, the one on the back with the parabola, that's the one you'll do at home and bring with you on Monday. Okay, so class activity 2, turn that one in today though. Okay, because I want to see what you promised that you would do for your next test. All right, and I'll see y'all on Monday.